This video is for section 3.3. Our objective in this section is to solve systems of linear equations in 3 variables. Previously, all of our equations have only had 2 variables, so now we're going to look at equations with 3. The process for this is basically to use addition multiple times. So what you're going to do first is you're going to choose one pair of equations, or 2 equations, and you're going to use addition to eliminate one of the variables. Then what you're going to do is repeat that process with a different pair. But the important thing when you repeat the process is you're going to choose 2 different equations, but you're going to eliminate the same variable. So if your first pair you eliminated x, when you choose the second pair you're also going to eliminate x. If in the first pair you chose to eliminate y, in the second pair you also have to choose to eliminate y. Once you do that, you're going to get 2 equations, each equation with 2 variables. Then you put those 2 equations together and use addition. So you're going to use addition a total of 3 times. So you're going to use addition on those 2 equations. That'll give you a single variable that you can solve for. Once you have that variable solved for, you're going to plug it into one of the 2 variable equations to find the second variable. Then you're going to plug both variables into one of your original equations to get the third. So we're going to look at example 2. As you can see here, we have 3 equations and 3 variables, x, y, and z. So we're going to start by picking 2. I'm going to go with the top 2, but it doesn't really matter. What you choose, you should end up with the right answer in the end. It's just going to be that the steps in between are going to look a little bit different. So I'm starting with the top 2 equations, and then I need to choose a variable to eliminate. I'm going to choose to eliminate x, although again it doesn't matter. I could eliminate the y, I could eliminate the z, I just need to pick one. So for the x's, I have a 5 in front and a 3 in front. So I need to multiply the bottom equation by 5, and I need to multiply the top equation by 3 so that they're both 15. I need to make one of them negative. I just need to pick one. So I'm going to pick the bottom. Again, it doesn't matter. You should end up with the right answer. Then I'm going to distribute those through, so distributing that 3 and distributing that -5. -3 times -5 is +15. You have to be careful with the arithmetic here, especially with the signs. One little mistake and that's going to make the whole problem off. So you want to be careful, use a calculator if you need to. X's are going to cancel out. -6 plus -15 is -21. -12 plus -10 is -22. And 9 plus 15 is 24. So that's eliminating one variable in the first pair of equations. Now I'm going to do the same thing with a different pair. So my second pair, I'm going to choose the bottom two equations. I could also choose the top and the bottom equation to work with. What I can't do is choose the same pair that I chose before. So I'm going to start by writing out the bottom two equations. Now, since I eliminated x with the first pair, I need to eliminate x with this pair also, so that in my result I have y and z. Otherwise, it's not really going to go together with the other equation very well. So to eliminate x with this pair, I see that I'm going to want to multiply the top equation by 2 and the bottom equation by 3. Note that I already have a negative sign in front of one of the equations, so I don't need to make one of them negative, because they're going to cancel out if I multiply both of them by positive numbers. So that's going to give me 6x plus 6y plus 4z equals -6. -6x plus 15y plus 9z equals 9. Add those two equations together. The x's cancel out as they're supposed to. 6 plus 15 is 21. 4 plus 9 is 13. -6 plus 9 is 3. So I have another equation that has just a y and a z in it. Now I'm going to put that together with the answer from my first pair and use elimination on those. So that's going to be the first equation. This is the second equation. So I'm putting these two equations together. Now, I have to use addition on this. This one, it actually works out really nicely, and I didn't realize it was going to work out like this when I chose these equations to work with. But as you can see here, I have -21y and 21y. So I don't need to multiply either equation by anything. That's just going to cancel out when I add them together. Now, normally that won't happen. Normally at this step, you'll have to multiply either one of the equations or possibly both of the equations by something in order to get one of the variables to cancel out. But I got really lucky here in that I didn't need to do that. So the 21y's cancel out. -22 plus 13 is -9z, and 24 plus 3 is 27. And lastly, I just need to divide by -9 to get z. Now, all of these in the homework, they should come out to be whole numbers. If not, that means you have some kind of mistake. So 27 divided by -9 is -3. Make sure that you're keeping that negative sign. Now I just need to substitute back in to get my values for x and y. So I'm going to substitute into either 21y plus 13z equals 3 or -21y minus 22z equals 24 to get y. I'm going to go with the one with the positive coefficients because I think that's a little bit easier. less likely to make a mistake with a sign if you're dealing with positive numbers. So 21y plus 13, plug in -3 for z. Sometimes the numbers on these can get a little bit big, but once you get down to it, they should, like I said, come out to be whole numbers for your variables. 3 plus 39 is 42, and 42 divided by 21 is 2. So that worked out nicely. So I have z, I have y. Last thing I need to do is find x. So I need to pick one of my original 3 equations from the problem and plug in the y value and the z value that I found, and then solve for x. I'm going to go with the top equation just because it doesn't matter. Any of the 3 equations, you should get the same thing if everything that you've done to this point is correct. So I'm going to plug in 2 for y, and I'm going to plug in -3 for z. So this equation, I'll write it out here. The top equation was 5x minus 2y minus 4z equals 3. So plug in the value you got for y, plug in the value you got for z, and solve for x. So this is going to be -4. Careful with this, -4 times -3, that's plus 12. Combine -4 and plus 12, and that's plus 8. Then I need to subtract 8. That gives me 5x equals -5. Divide both sides by 5, and I get x equals -1. Now the way that you're going to enter this into the homework is you write the coordinates as x, y, z. And make sure that you put them in parentheses, just like we've been doing. You'll see on the homework, kind of like how we've had, there's going to be other answer choices. Don't worry about those. All of the problems that we're doing should work out so that there is an answer and you get numbers for x, y, and z. So we have -1, the y that we found is 2, and the z that we found was -3. So that's my answer. It's kind of a long problem, but it's just a lot of the steps to do. So what you're going to do next is checkpoint problem number 2. Right here. Do this problem in your notes, check your answer with the notes that are posted, and then you can move on to the homework problems.